Assume the following patterns are built of square tiles and the pattern continues. Before we answer our questions, let's analyze the figure. In the first one, we have one square. In the next one, we have 1, 2, 3, 4, and then you're adding one square. The next one we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We already had one square added, so now we're adding another one. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now we're adding an additional square to the previous two. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. And then again, we're adding an additional one square to each one. Okay? Now, if you notice here, this is the same thing as 1 squared. This is the same thing as 1 squared, or we can say 1 squared is, well, before we write the square, let's just write that as 1. Okay, and then we have 4 squares plus 1. And then here we have 9 squares, right? And then we're adding 1 and then another 1 from the additional one, right? And then we have 16, and now that's plus 1, plus 1, plus 1. And the next one we have 25, which is plus 1, plus 1, plus 1, plus 1. So that means we're adding 1 to the perfect squares, because 1 is a perfect square, 4 is a perfect square, 9 is a perfect square, 16 is a perfect square, and 25 is a perfect square. So that's just discovering what our patterns look like. Now we want to figure out how many square tiles are there in the sixth figure. Okay, well, we know that how many total do we have? We know that there are 1 total squares in the first one, there's 5, then there's 11, then there's 19, and 29 tiles in the first 5 figures. Now each figure adds an additional 1 tile to the preceding figure. So if we wanted to find the sixth term, we know that it's going to be a perfect square of 36, and we have 1 plus 1 plus 1, and we're adding another one, which would be plus 5. Therefore, that would equal 41 tiles. Now the next question says, how many square tiles are in the nth figure? Well, again, if we look at the base of the perfect squares, n squared is 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. Now, we're adding an n minus 1 to the n squared. And that's what that means, is we're adding an n minus 1. So, the way we would look at this is the following. Therefore, we would get 1, 5, 11, 29, 19, 29, 36, which is the proper sequence. Therefore, the nth term has n squared plus n minus 1. The n squared is the perfect square, and then we're adding an n minus 1. Now, is there a figure that has exactly 1,259 square tiles? And if so, which one? We're going to bring a little bit of algebra in here now. Okay, so that means we're going to let this nth term, n squared plus n minus 1, equal the total amount of exactly square tiles it's asking this question, which is 1,259. Now, we need to subtract the 1,259 to the left side so we can set equal to 0. When we subtract that, we end up getting n squared plus n minus 1,260, which is equal to 0. Okay, so now what we want to do is we want to factor. So if you remember, when we factor, we have ax squared plus bx plus c equals 0. Okay, so what we want to do is we want to find a number, or a pair of numbers, that when we multiply it to get c, and we add them together, it's going to give us b. So the value of c in our problem is minus 1260. And we want to get the value of 1, because if you look in front of the n, it's a 1. So we need to find two numbers, and when we multiply them together, it's going to give us negative 1,260. We add them together, it gives us a positive 1. Well, the two numbers are negative 35 and positive 36. And so we ask ourselves, negative 35 times positive 36 gives us negative 1,260. When we add them together, it gives us positive 1. So now we're going to write it in factored form. So that means we're going to end up getting n minus 35. So if you look over here, is minus 35 times n plus 36, which is equal to 0. Now we got to set them both equal to 0. So n minus 35 equals 0, or n plus 36 equals 0, meaning that there are two possible solutions. Now when we solve for the first n, we have to add 35 to both sides. When we solve for the second n, we're subtracting 36 to both sides. So that means n is equal to 35, or n is equal to negative 36. Well, we don't want a negative answer, so we have to eliminate that one. That means that n is equal to 35. Therefore, there are 1,259 tiles in the 35th figure.